Hello students, I hope you all are fine. Today we are going to discuss a new topic, that is composite function. So what is composite function? The name says it is something like composition of function. Means in simple language we can say that it is a mixture of two or more functions. How? Suppose we have two functions. The first function is f a to b. That means function f has this domain. This is set A and its codomain is b, set B. So when we are putting element x from the domain, we will get the value fx. So fx belongs to B. Now we have other function, that is let it be defined as g b to c. That means domain of the function is B and codomain is C. We already have this set B, which is the domain of function G, and we will have here a set C, which is the codomain of function G. So now in function G, this fx will act as a domain element of the domain. That means when we put this fx in this function, we are going to get the value that is g of fx. This g of fx is the element of set C. This type of function, when we are putting the value from one set, we are getting the value of the function, and this value of function will act as a element, and then we will get other value by using second function. Same way we can use other function, third function also. So this type of function is called composite function. Now we made composition of function, we combined two or more functions. So this is called composition of function. We represent composite function as GOF. GOF means G of fx. That this is the representation of a composite function GOF. To define any composite function, we have to consider a very important criteria. That is, the range of function fx must be the subset of domain of function gx. That means we can write it that range of f must be the subset of domain of G. Okay, that is the only condition. This is the necessary condition when any composite function is defined. That means whatever the value we are getting, this fx means set of range, must be the subset of set B, because B is the domain of function G. This is the only condition when any composite function can be defined. Now we will understand the composite function with an example. Here we have a question which says that the f function is given. Here in this question, the function is defined as 1, 2, 2, 3, 4, 5. We have second function g, which is defined as 2, 3, 3, 5, 5, 2. Then we have to find FOG and GOF, whichever is possible. So before finding any composite function, first we have to check whether the function is defined or not. To check whether the given function is defined or not, we have to check for this criteria. For that, we have to find the domain and range of both the function f and g. So how to find the domain and range of function f and g? To find domain, we will consider this function. So we have a function f, domain, this is the domain of function, this is the range of function. So here it is clear that when we are putting 1 in the function, we are getting 2. When we are putting 2 in the function, we are getting 3. When we are putting 4, we are getting 5 from the function f. So we can simply write it 1, we are getting 2, when putting 2 we are getting 3, when we are putting 4 we are getting 5. This is function f. So from here we can simply find out the domain of function is 1, 2, 4 and range of the function here is 2, 3, 5. Now, so let us write this. So domain of function, domain of f is equal to 1, 2, 4. And in the same way we can write range of is equal to 2, 3, 5. Now we will find the domain and range of function g in the same manner. So now we will find the domain and range of function g. Here we have a function g here, which domain is this set, and here we will write its range. So from the function we can say that when we are putting 2 we are getting 3, when we are putting 3 we are getting 5 here. Now when we are putting 5 we are getting 2. So 2, 3, 5 are the domain of function. So we can write domain of g is equal to 2, 3, 5 and range of g, range of function g is equal to 2, 3, 5 again 2, 3, 5. So here we have the domain and range of function f and g. Now we will check whether the function is defined or not by using this criteria. So here first let's check for FOG. Write the function FOG, that means function f of gx. Always write FOG as f of gx. That is the meaning of FOG. Now to check whether this is defined or not, we have to check the range of gx must be the subset of fx. So what is the range of gx? Range of gx is 2, 3, 5 and domain of f is 1 to 4. Is 2, 3, 5 is the subset of 1 to 4? No, because elements 3 and 5 does not belong to the domain of function f. Hence we can say that they are not the subset. Hence we can say that range of g, range of function g is not the subset of domain of function f. Hence we can write, hence FOG is not defined. Hence the composite function FOG is not defined. Now in the same way we can also check for GOF. Let's check for GOF. First write the function GOF, that is GOF. The GOF means g of fx. So we have to check here the range of function fx must be the subset of domain of function g. So let's check it. So what is the range of function fx? Range, this is function f. Range of function f is 2, 3, 5. Now the domain of function g is also 2, 3, 5. Hence here both set are equal. Then we can say that range of function f is a subset of domain of function g. Hence GOF is defined. Hence we can write hence GOF, hence composite function GOF is defined. So now we will find function GOF. So to find function GOF, first we will find what is the domain of function GOF. And we know that domain of any composite function is the domain of first function, and first function here is fx. So what is the domain of function f? Domain of function f is 1, 2, 4. So we will check it for one by one. For first value 1, GOF 1 is equal to G of F1. G of F1. F1 means f of 1 is 2. So we can write G of 2. G of 2. Now it comes the role of second function G. Now when we put 2 in the function G, we are getting 3. So G of 2 is equal to 3. Second element is 2. So G of 2 is equal to G of F2. Now F2 is equal to 3. So we will write G of 3. G of 3. When we are putting 3 in the function, we are getting 5. So G of 3 is 5. In the same way, we will check for the last element 4. So G of 4 is equal to G of F4. G of F4. F4 is equal to f of 4 is equal to 5. So we will write it G of 5. G of 5 will give us 2. So it is equal to 2. Hence 3, 5, 2 are the range of composite function GOF. This is how we will find the domain and range of any composite function. By using this question, we learned how to check whether a given composite function is defined or not, and if it is defined, then how to find its domain and range. Now here we have second type of question which is asked from this topic. Here the question says that we have to find GOF and FOG if f is defined from real number to real number, g is defined from real number to real number, are given by their rule is given fx is equal to cos x and gx is equal to 3x square. Now we have to find FOG and GOF. To check whether the required composite function is defined or not, we have to check the range of first function must be the subset of domain of second function. So for function GOF, we know GOF means G of fx. Here the first function is fx. So we have to check the range of fx must be the subset of domain of function g. So range of f, that is R. Hence we can say that this function GOF is defined. So now we will find function GOF. So GOF means G of fx. Value of fx is cos x. So we will put cos x here. The G of cos x. Now G of x. G of x is defined as 3x square. So in place of x we have to put cos x. So we will get 3 cos x square. It can also be written as 3 cos square x. This is the function GOF. This is the composite function GOF. In the same way, we will define composite function FOG. Now FOG. FOG means f of gx. Now we will check the range of function gx must be the subset of function f. Range of gx is real number. Domain of second function f is also real number. They both are equal. Hence the composite function FOG is defined. If it is defined, then we can find its expression. So f of gx is 3x square. So it will become f of 3x square. Now in place of x, we will put function will become cos of 3x square. This is the function f o g.